Welcome back, everyone, to another Deep Dive Explainer. Today, we're tackling a topic where the margin for error is literally zero: process safety metrics. Specifically, we're going to break down the extremely strict standards used in the biofuels, petrochemical, and refining industries. We'll be pulling our methodology straight from the SASB framework. If you've ever found yourself wondering how these massive industrial facilities quantify, track, and ultimately correct their absolute worst safety risks, well, you're in exactly the right place. We're going to make these complex engineering metrics completely accessible. So, within the SASB biofuels standard, there's just this massive framework of accountability. We aren't going to get bogged down in things like air quality or water management today. Instead, we're focusing squarely on that bottom row: operational safety, emergency preparedness, and response. Specifically, we're looking at metric code RRBY-540A.1. This single line item represents a rigorous, highly specific methodology that forces these huge industrial facilities to confront their most dangerous vulnerabilities head-on.
Here's our roadmap for today. First, operational safety hazards. Second, the ANSI/API RP 754 methodology. Third, process safety incidents count. Fourth, the total incident rate formula. Fifth, the incident severity rate formula. And finally, number 6, analyzing causes and corrections.
Let's start with Section 1, Operational Safety Hazards.
Okay, let's dive into this by first acknowledging the intense physical realities of biofuel production and refining. I mean, we aren't exactly talking about a typical office environment here, right? Every single day, these facilities manage vast, mind-boggling quantities of highly flammable and explosive substances, stuff like volatile ethanol or methanol. They operate using extreme heat, and they rely on massive, complex networks of highly pressurized equipment. When you combine flammability, extreme heat, and high pressure, the margin for error is incredibly slim. Process safety incidents might be rare, but when they do happen in this kind of environment, the physical outcomes can be utterly catastrophic. Not just for the facility itself, but for the local environment and the surrounding communities.
And those physical hazards, they trigger an immediate domino effect of severe financial and operational consequences. Think about it. If a pressurized tank ruptures or a fire breaks out, the immediate, most pressing tragedy is obviously the potential for injured workers and severely damaged facilities. But from a purely operational standpoint, that facility might literally be offline for months. That means totally lost revenues at the exact same time the company is bleeding capital for massive repairs. On top of that, companies with poor safety controls face a much higher cost of capital from hesitant investors, not to mention mounting regulatory penalties and litigation. This is exactly why investors, regulators, and managers track this data so obsessively.
Moving on to Section 2, ANSI/APRP 754 methodology.
To prevent the chaos we just talked about, the industry needs a systematic way to track performance. The SASB standard explicitly aligns with the American Petroleum Institute's recommended practice 754. Most folks just call it API-RP 754. I want you to imagine a giant 3D pyramid. At the very top of this pyramid, we have Tier 1 process safety events, or PSEs. These are the worst of the worst, the most severe incidents, like major releases of hazardous materials resulting in serious injuries, fatalities, or massive financial damage. Now, just below that, we have Step 2, Tier 2 process safety events. These are still very significant, but they're less severe releases or incidents. This hierarchy is absolutely crucial because it forms the fundamental baseline for all the quantitative metrics we're about to calculate.
Section 3, Process Safety Incidents. Count.
Now that we've got a handle on the tiering system, let's look at our first core metric. We're going to build these mathematical formulas incrementally, piece by piece. The Process Safety Incidents Count, or PSIC, is exactly what it sounds like. It is the absolute, raw, annual count of all incidents that meet the rigorous definition of a Tier 1 process safety event. So if a facility has 3 major explosions or toxic releases in a year, their PSIC is simply 3. It's that straightforward. It provides the foundational raw baseline number of severe annual incidents.
Which brings us to Section 4, Total Incident Rate Formula.
Now, a raw count is helpful, sure, but how on earth do you compare a sprawling, massive global refinery complex that has thousands of workers against a small regional biofuel plant? You can't. Not fairly anyway, without normalizing the data. That is where you use the Process Safety Total Incident Rate, or PSTIR. This metric takes that cumulative annual count of incidents we just talked about, and it normalizes it by man-hours. This gives us a rate that can be accurately and fairly compared across facilities of completely different scales.
Okay, here is exactly how that math works under the RP 754 standard.
Step 1. You take that raw process safety incidents count, your PSIC. Step 2. You multiply it by 200,000. Now you might be wondering why 200,000? Well, that number represents the equivalent of 100 full-time workers working 40 hours a week for 50 weeks a year. It's the standard baseline the entire industry uses. Then, step 3, you divide that product by the total annual hours worked. But pay super close attention here. Actually, scratch that, this is vital. The SASB standard strictly mandates that this includes hours worked by employees, contractors, and subcontractors. You cannot artificially lower your incident rate by outsourcing your absolute most dangerous jobs to independent contractors. Their hours and their safety incidents are fully 100% accounted for in this denominator.
Let's look at Section 5, Incident Severity Rate Formula.
So we've got our raw count, and we have a normalized rate based on how many hours were worked. But simply counting the frequency of incidents isn't really enough. The methodology demands we also measure the exact severity of those events. How bad were they actually? Enter our third key metric, the Process Safety Incident Severity Rate, or PSISR. Notice the key term here, severity weighted. Because let's be real, not all Tier 1 events are identical. One might cause a brief, localized shutdown, while another might cause catastrophic facility destruction. This metric mathematically accounts for the true impact of the events.
Notice how this math builds perfectly on the logic from the previous slide. The structure is practically identical to the total incident rate. You still multiply by that 200,000 baseline, and you still divide by the total annual hours worked by all employees, contractors, and subcontractors. The only thing that changes is the numerator in step 1. Instead of swapping in a simple count of incidents, you input the total severity score for all those Tier 1 events. This allows regulators and investors to see not just how often things go wrong, but how destructive they actually are when they do.
And this brilliantly illustrates the complete quantitative picture. Side by side, we have our three metrics. First, PSIC for the absolute count, using all Tier 1 incidents as the input. Then PSTIR for the normalized rate by plugging the PSIC into the numerator. And finally, PSISR for the severity-weighted rate by swapping the count for the total severity score. Together, these form a comprehensive X-ray of a facility's operational safety record.
Finally, Section 6, Analyzing Causes and Corrections.
So doing the math is only half the battle, because at the end of the day, numbers on a spreadsheet don't prevent the next explosion, right? So we have to ask what actually happens after a Tier 1 or Tier 2 incident is recorded and calculated. How does this reporting framework actually force an organization to improve?
Well, the SASB standard is highly specific here. Entities cannot just report the metrics and move on. No way. For any incident with a severity rating of Tier 1 or Tier 2, they are explicitly required to publicly detail the root cause of the incident. They have to document the specific outcomes, what actually happened to the people and the plant, and most importantly, they must implement and report the corrective actions taken in response. The standard even gives specific examples of what these actions should look like. For instance, if a root cause analysis shows a specific type of pressure valve failed, the corrective action isn't just sending out a company-wide memo, it's funding actual technology improvements to replace those failing valves across the entire plant. It strictly links the reporting of outcomes to real-world mandatory corrective actions, proving that a strong safety culture responds effectively to mitigate future risks.
Which leaves us with this final, completely crucial thought. Whether you're an investor looking at a biofuel refinery or a manager overseeing a massive industrial operation, does your safety culture merely calculate incident rates to satisfy a spreadsheet, or does it aggressively correct their root causes? The API RP754 standard isn't just about math, it is a blueprint for accountability. Take these metrics, look at the denominators, scrutinize the severity weighting, and absolutely demand that qualitative root cause analysis. That is how we turn abstract data into genuine operational safety. Thanks so much for joining me on this explainer, and as always, keep learning.